All right. So, good evening, everyone. I think we are meeting after a long time now. I think we had our last session 15 or 20 days ago. So, we are now moving on to the final part, that is VR and AR development. But before we move on there, we'll do a quick recap today of what we have learned. Just I'll walk you through what we have made, and then there are some things that we did not uh, like some important topics that we did miss studying during this thing. So we'll quickly go through one or two of those topics, and then we'll move on to AI development, starting with that today. So the remaining sessions, there are 8 remaining sessions. I'll try to make it 4 AR and 4 VR, and yeah. So just a second. Yeah. So let's start with this. Uh, So basically, so what we did, like if you can see on the screen, we did a lot of things while in the last almost 10 to 11 sessions, which was completely focused on concepts that we generally use in shooter games, but these concepts can be used anywhere that we want to use. So we learned a lot of things. Maybe like seemed like that we are doing small things and building a small game, but if you look back, we have learned a lot of things. So uh, I'll just quickly uh, show the final project version that is there on GitHub, and that you can access whenever you want, and in the future also. So this is the most final version, I think. And last we ended up creating the like we went through all the things. We started with basic setting up the scene, learning the difference between first person and third person, adding 3D characters. So we learned about Mixamo, which is an important tool that you'll use in VR as well. So Mixamo will be very useful going forward whenever you want to create characters and prototype for characters, at least at your level when you're building your portfolios and building prototypes. That time Mixamo and some other tools similar to Mixamo like Ready Player Me is one new tool that we have not explored, but I'll share links with you and you can explore that. So these kind of tools will be very important when you're creating your portfolios and prototypes. We learned about coroutines, raycasting, adding like the whole system of shooter games, where adding enemy damage as well as enemy attack, then player damage as well as player attack. And we learned animations, we learned about nav mesh, we did a bit about pro builder, like prototyping in Unity directly and how to use pro builder in Unity. We did a bit of that. Then we learned a bit about adding AI to enemy and how we can do that, how we can create a basic state machine. So we did not move on to probabilistic state machines and stuff like that, but we did create a very basic finite state machine AI, right? And then we looked into some effects like particle effects for bullet shooting, and uh, blood effects, wall effects, animations for the gun, all those things. Then uh, a concept of respawning for the enemy, for the player, and respawning of the enemies in the scene, dynamic spawning, and health bar and all those things. So basic things that we covered. So eventually, this is uh, what we finally built. made this for player pickups. If you remember, I think green was for ammo and red was for health and something like that. So this is what we ended up creating. Final screen is a bit iffy, but yeah. So yeah, so this is the final result, and I hope you guys can fix this on your own now. So like a complete game we created. If we restart, uh, when we can, I think something's wrong here. But yeah, some minor bugs and all, obviously. But other than that, I think this is the final thing that we created. So going forward, try to remember concepts and not like try to remember concepts as a general thing and not specifying that concept with a specific, like remembering them in the context of just shooter games. So like things like how to use and exporting a Unity package, like they can be used anywhere. How to use particle effects, like we used it for weapon effects, but what if we want to use it somewhere else? So things like that, they apply anywhere, right? So this is all, I think, and like we are done with uh, shooter games. And I think let's see what we'll build in VR. I have not thought of that yet. But if we want, we can just take this and convert this to VR for the VR part. For AR, there's a small concept that we'll go through to familiarize. And if we have time, then we'll also go through Spark AR, which is Facebook's Meta's AR system other than Unity. So it's a different software that we might go through if we have time. So moving on from that, let me close this. So if there are any questions regarding this, whatever we have gone till through now, and any doubts, or if you want to showcase what you have done till now, uh, if there's anything like that, then we can do it right now if you want, or we can have a separate meeting for that as well. So if someone has anything, someone wants to show something, talk about something, discuss a specific topic, please, you can unmute yourselves as well as raise your hand or whatever. Otherwise, we'll move on to the next thing. Okay,
So I
so I
did.
guess we'll
Oh,
move.
sorry.
Yeah, Akshat, go ahead.
I did start with a very basic program of sorts. I made what
Okay,
you call a, you know, how do you say it? A reflex trainer, as in like in
okay,
FPS shooters.
yeah,
So
yeah,
it randomizes a target and you just uh, shoot it, and then the positions
okay,
of them
okay,
change constantly. So I'm thinking I'll further make it better. I could
sure.
show it if you'd like to see it.
Yeah, if you want to, you can share your screen now and show it.
It's just importing all the other things, so I'll show it as soon as it
Yeah,
loads.
yeah, sure, sure, no worries. So that's a great step. And like now, like after like few slides, I'll talk about building portfolio as well. So we'll talk about how you can better enhance what you have already made and how you can actually showcase that. So I'm basically creating a guide on how you can create portfolios, but it's not complete yet. But I'll keep on adding resources there. But we'll talk about that next. So Akshat, just let us know when your loading is done. Till then, we'll move ahead. Okay.
It's done, sir. I can show it now.
Okay. Yeah, yeah. Okay, great.
So this is what it is, sir. Just a second. So essentially, I'll just start it. So what it does is every time you click on it, the positions change.
Yeah,
So the plan is to add a UI, give it like a score, a time limit. So the faster you
yeah,
do it, the better your score is. And that's currently all I have. As you can see, it's very basic
yeah,
right
yeah.
now.
No, but a
Even
great
the
start, great start. And then you'll need to plan more as to what you want to exactly implement and how do you want to add the scoring, those things. But yeah, great start.
Thank you, sir.
Okay, so back to this. So yeah, so moving on from shooter games, we missed a few things that we did not talk about at all, which was mostly with respect to how to optimize our games with respect to how it looks, like basically trying to make it look better. And there are a few things that we basically use for that. So render pipelines is one of those things. And the other thing that we did not talk about at all is lighting. So lighting is one of the things that basically uh, controls how your screen looks, right? So that is one thing that we did not talk about at all, and I'll just discuss that quickly here as well, some right now. And one of the third things which we did not talk about at all is post processing. So you must have heard the term post processing in image editing or video editing, where basically you like if you've done any video editing, they'll people generally record random things and they'll be like, we can fix it in the post processing. So like if there's something that's wrong with the way that you have recorded a video, you can fix that in post. It's what is generally thought of. So what that means is basically that let's say if I took scene which was very low light and I took a video shoot, I shot a video there, but later I realized that lighting was not very good while I was shooting. So software tools provide us the opportunity to fix that while we are uh, like editing the video or editing it, right? So the same thing can be applied in games as well, where basically if you're whatever you've implemented, lighting and all, if eventually if you want to change some of the things, you can do that in post processing. So Unity has different post processing stacks, which are part of render pipelines itself. So what are render pipelines? Render pipelines are basically a series of operations that take the contents of a scene and display them on a screen. So it's just like what you're actually seeing in the game view finally is what render pipeline is building from your scene view to the game view is what render pipeline is basically doing. So till now we have been using the built-in render pipeline which Unity provides by default. So if you remember, and I'll show you also. When we go here, when we create a new project, we have options to select two more things. If you look here, URP and HDRP, right? So, but whenever we have done till now, we have selected basic 3D. So this basically, it says here clearly, this is an empty 3D project that uses Unity's built-in renderer. So what we are doing is basically using the built-in rendering pipeline. Why did we use this? Because URP and HDRP, they are a bit different. A bit of initial setup is required, which was not required for the things that we were building. But maybe we'll try to use this in AR because AR core, I think, expects URP pipeline. So we'll see even if it is not required, we'll try to use URP going forward. But so this is one of like the resource that I was telling you that I'm trying to build. So this render pipelines is one of the things that is here, which is just has a few links. So we'll go through them quickly once. So we talked about this render pipeline performs a series of operations that takes the content of a scene and displays them on a screen. So what this basically means is scene view measure them like whatever we fit in the scene view, whatever we have created, how that displays in the final game is what the render pipeline is doing. And at high level, it is basically doing these things, culling, rendering, and post-processing. So the post-processing thing is the third thing that I told you that we did not talk about at all, is one of the parts, right? So next, what we have is basically a big document which compares different things that are provided in all the three different pipelines. So before that, so built-in is basically the default render pipeline that Unity gives. It is a general purpose render pipeline that has some limited options for customizations. Then URP is, so like what is URP and HDRP? Where do they come from? Like what are these new things, right? So basically Unity and other game engines, they introduced scriptable render pipelines. So basically till now, like before scriptable render pipelines, you did not have the ability to change the rendering behavior on your own. But now you can create your own render pipeline. So like, right, it says in the very end that you can also create, you don't have to use these three only, you can also create your own as well. So that is the ability that scriptable render pipelines allow us, which basically means that you can write your own code that will take the scene view and convert it into the final game view. Okay. But Unity is also providing you some scriptable also. By default, it is trying to give you some options. So as the name suggests, it is very clear, universal render pipeline. If you want to use a scriptable rendering pipeline, then universal render pipeline is like a replacement for the built-in render pipeline straightforward. It is going to give you a lot of different customization options, and it is for a lot of different platforms, not restricted to specific platforms. And then high definition render pipelines would be restricted to specific platforms, and it is like for very high fidelity graphics that you want to create. So the post processing effects and all those that will be available in HDRP would be aimed towards creating high graphics. Sorry. Sorry. So yeah, so this is what HDRP and URP give us. So before URP, if you read a bit about history, there was also a low definition render pipeline, LDRP, as well. And that basically got converted to URP, I think last year or somewhere before that. So coming to what all, like, it's a long list. We'll go through only a few things in this, and in that we'll also talk about lighting. This will give us a chance to talk about lighting. So as you can see, almost all the things are supported by built-in render pipeline as well as the URP. So if you can see, that is why I said it's almost a replacement for built-in render pipeline when you want to use a scriptable rendering pipeline, because it is supporting almost everything. But when you go to HDRP, you can see that it is not supporting Nintendo platform, iOS platform, Android platform. It's not supporting mobile VR, HoloLens, as well as WebGL. So HDRP, as you can see, is mostly for Windows-based or like desktop-based games, or the like PlayStation and Xbox series kind of games, right? And it's not available for mobile devices as well as web, is like your main concern. So HDRP we won't be able to use HDRP when we want to create mobile games uh, or games for the web, is one of the major factors. But if you want to create game for, let's say, putting up on Steam, which is a major uh, platform for desktop games, so then you can, if you want, you can use HDRP, because it will give you good options in post processing, right? So coming to lighting again, uh, there are obviously so many different things to consider, but like in general, when you go to Unity, you can add like directional light we have seen, because this is by default added and this is present as is on all of them. Then there are three different more kinds of light that are available in general. If you don't do anything else, if you don't want to see anything else, then these are the three other general options that you'll see: spotlight, point light, and area light. Generally in Unity, if you right click and or add a component, then you'll see these three different lights under lighting as well. So spotlight is basically a light where basically it will it it's a point, and then you can define the shape and uh, like at a very specific spot, that like what is the sorry, in this you don't define the shape, it's a conical shape only for built-in and URP. As you can see, the shape has been written. So conical, it's like basically think of a street lamp. So if you have a street lamp, it is basically a conical presentation of light. So that is the spotlight. You can have a spot from where the lighting is supposed to be showered, and it will spotlight the one spot. So street lamps or like stage lighting, if you remember. Yeah, sorry, just a second. Yeah, sorry about that. So yeah, so point light is one of those lights like stage lighting and all, where you want to spotlight is stage lighting where you want to give a specific spotlight. So obviously it would have been better if I explained it with Unity, but I don't want to give it that much time. So that's why I'm explaining like this. You can explore these things on your own. So point light, again, you have a specific point and then you can like go out and you can define a range which it should specifically illuminate basically. And then area light is that you define a specific area that it should illuminate. So, and then this link would be available to you. You can come here and see what different pipelines are supporting. But in general, these are like support every different built-in as well as URP and SDRP are supporting all the four options. And then there are specific like options that are there in lighting. Uh, like these are the kinds of light that are there. And then these are the different features that are there inside the lighting. So you can look into this as well. And then moving on to, there are shadows which are part of lighting as well. So what kind of shadows are available in built-in URP, SDRP, you can come here and read. Similarly for global illumination, right now we were basically using for global illumination, we were using the or directional light. So what other kinds of global illumination can be there? Baked global illumination is a very big concept. And then real-time global illumination is there, which is also present here, which is not available in built-in as well as the URP. It is available in HDRP. So if you so this is very popular in Unreal Engine. So there are two things that Unreal Engine recently, not recently, it has been almost 1 year, I think now, launched two things. One was Nanite and one was Lumen. So these are two things which are basically for global illumination plus rendering millions of triangles at once in real time. So which made Unreal Engine very popular. So you can look into that and how Unity is covering up for that. What are the tools that are available in Unity for those things? Then light probes, reflection probes, these are basically things that you keep in your environment. I think we tried reflection probes till now, I don't remember. If not, then we can try in VR reflection probes. We'll basically use for mirrors and that kind of surfaces. We can try using reflection probes. Light probes are basically kept in environments to basically reflect off of surfaces. So you have a light. If you keep light probes near surface, if you move like whatever light is going through that surface or bouncing off of a surface, that will basically try and show off like from there. So it's basically blending the how natural light is, how light bends, like it falls on a surface, then it uh, like refracts to another surface. So this is basically how to basically kind of replicate how a natural environment behaves, you basically use light probes. Ray tracing, part tracing, like again, a lot of concepts are there. We have also talked about skybox. So again, different options are there. So as you can see, built-in and rendering URB have similar uh, skybox concept, but HDRB does have a different like you can have different concepts in HDRB for skybox as well. So again, camera also there are many different options. Then shaders we have not talked about. Shaders also is one of the big topics that we have not talked about, which is like not for this course as well. Like it's like this course is an introduction or a foundation course. So once you're familiar with the concepts here, then you move on to these things and learn these things. So yeah, so yeah, post processing is like the final thing that I want to talk about. And do I have it open somewhere? Yeah, so this is post processing. This is like an effect, like how post processing can change your scene. So this is a scene with no post processing, and this is a scene with post processing, right? So as you can see how dull this scene is looking, and then how sharp and how bright all the, like you can actually see all the different components lighting as you would kind of see in a natural real environment, not just it won't look uh, like a simulated environment. It will you can make it behave like how a real environment would behave. Uh, and yeah, then basically there are different kinds of effects. So for post-processing, basically there is a post-processing stack, which is for built-in render pipeline. It's available as a package, but when we use URP or HDRP, it comes wrapped inside. So post-processing is available in URP and HDRP as is. But obviously, again, there are different features available in all these things, which are available here if you want to go through this. And this also, I think I have not added. I'll add this. So this was about basically post things that we have missed out with respect to quality of the scene in a sense. So render pipelines and lighting and post processing. Uh, yeah. So this has, so as for XR also, if you see, we have different options available for XR. So as you can see for AR foundation, for using AR, which is basically mobile based AR or HoloLens based AR, uh, it is available in built-in render pipeline URP, but not in HDRP. Similarly, some of the things are available for uh, this thing, but not for HDRP. So generally in XR applications, or like whenever we are creating, let's say for Oculus or uh, mobile based VR, then we should basically go with URP or built-in render pipeline. If you're prototyping, then just use built-in render pipeline. It's straightforward. You don't want to use much things, but for production ready, you can go with URP. And then if you're basically, let's say, working with HTC Vive or a bigger uh, any other product, which basically now they are reducing, but yeah, then we can go with HDRP as well. And that's it. So this is a good document to go through once you start understanding what uh, uh, like rendering pipelines actually provide you, what you should like, how you can leverage those things. Then you can start going through these things. Okay, so yeah, coming back to the slides. So if there's any doubt in this till now, uh, anyone wants to ask anything here till now, if there's anything, otherwise we'll move on to basically creating your portfolios and how to go about doing that. Just have some water. All right. Uh, so I think now, like we in our project, like till 2022 sessions till now, what we have done is we have made three different games. One, a very basic game. Second one, a bit complex, but again, straightforward game. And third, a bit more complex, but still straightforward. Now, it is up to you to either recreate those games and create your portfolio, or basically, if you want, just focus on one game and create a portfolio project. So, but like if you want to go into XR or game development or this kind of field going forward, then you need to start seriously building your portfolio. And what basically a portfolio means is that you have a project where basically some of these things are there. So, like a game design document should be there, a case study kind of a thing should be there, like why have you chosen this, or uh, what is the impact, what are the different things. Like we'll just go through game design documents and you'll see. Then it should be playable instantly. So the best thing to do would be to create a web-based version of the game. If it is for like a basic, just a game thing, not VR or AR, then the best thing to do would be to create a web version, or if you want a mobile version. But mobile version, the issue is that you'll have to share APK, they'll have to install. So that is why the best way to go for a game dev portfolio is to create a web-based uh, portfolio, web-based project. And almost all projects you can port to web-based, right? Which are playable on desktop, not on mobile at least, but at least they're playable on desktop. So try to create a web-based project, which is basically you just have to provide a link, and we have already seen that. So you should have a published project for your portfolio. And if you are creating a mobile game, then try to publish it on Play Store and learn those things as well. So deployment is an important part. A lot of companies, when they're hiring, not big companies, but at least small companies, startups, they'll look for people who have knowledge of deployment more rather than development. So, what is the general pipeline that we follow is written on the screen. So you plan the scope of the project. So this will basically include narrowing down what genre you want to work in. Is it going to be a shooting game or an endless runner or an adventure game, some kind of an activity game? So this is where you like jot down an idea of what you want to build, right? And then you define kind of the scope of the project in terms of uh, like limit the project, because a project can be extended to 1,000 years as well as be completed in 2 weeks. So limit the project depending upon your current scenario. So if you are in final year and you have to start applying for jobs, you have to start applying for companies, then choose a project which is like which won't take you more than a month to make and deploy and everything. If you have time, if you are a first year or a second year student, then go for a project which basically like you can go for multiple projects also in that scenario. So start building a scope, then like maybe weekly, like if a project is going to take you 1 week or to plan, then it will take you next 2 weeks to develop. So spend a lot of time on planning the project. So planning would also include the game design document, which we'll go to now. So this link I'll share with you, which is also again in this thing only. Uh, and this will basically, I'll add more resources here, but this is what I have. And I forgot to add a few, I found a few good portfolios of a few people. So few people as well as companies as well. So I'll add those, but I'll share this with you then. And then we have a sample game design document, which is here, which is basically developed by a company called Double Coconut, which is, I think, a game development company. I just found this somewhere randomly on the internet, but it is a very good document. And if you learn how to do this, this is basically game design is also a separate job in which basically you just have to create this document. You don't have to develop anything, but you do have to create this a game design document. But a game design document includes a lot of things. So these are the things that are included in this. So you want to start with target platforms, then business model. Business model is basically, I think I'll have this here. Yeah. So you start with target platforms and business model, then defining the genre, theme, then core mechanics of like what are the scoring, how is the player going to interact, what is the scoring going to be like, all those things, right? And then obviously a lot of things are there in this. So we'll go to some of those things. So target platforms, then business model. This is like obviously pick and choose wherever you want. Right now, when you're building for your portfolio, you don't need to add these things. But if you can like add these things as well, like if you see a lot of hyper casual games, they have reward videos and all those things. So you can, it's better to know these terms, right? Like what are freemium, what is a premium, what is a rewarded video ads, what are in-game purchases, how can you implement those? You don't have to implement them, but you can at least include those things in your document while you are creating your portfolio. Then uh, like this is part of your planning of the scope of the project, is basically trying to define like what genre is it going to be, what is the theme of the setting, all those things, right? uh, this like you can pick and choose. It obviously has a lot of things. Then this kind of a flowchart of how the whole gameplay is going to be. What is the uh, like where does it start? What will be the next scene? What will be the next scene? Uh, when does the game end? When does the game uh, win? When does the player win? When does the player lose? Those kind of scenarios. You can create this, and then generally it's if you're creating a mobile-based game or a uh, any kind of game, you will generally give gameplay screens as well here in Switch. So when for your case, what you can do is once you have created the game, then you can add these screens. Like you can ideal scenario is that you first create wireframes, basic wireframes, then you go on and create your games, develop your games. But let's say if you are less and low on time, then you don't have to go through this process. You can come back and do this as well. But ideal scenario will be that only. So again, a lot of things. This basically talks about how games should be like with respect to time and skill level as well as challenges. So basically, this would uh, the x-axis can signify sorry can signify time as well as skills, right? So yeah, so economy and all those things, I don't think you need to go into. Asset list is one of the most important part that you need to define while you are uh, creating the game design document. So you can add links to where you want to take 3D objects from, where you want to take textures from, where you want to take audios from, all those things. You add it in the asset list here itself. And that's all. So this is a sample outline of a design document. And if you can convert this to a web page, and when you create up your portfolio, this would be your first screen. And somewhere here you will write play, click here to play. And then all these documents, information is going to be below as a web page. So this would be one of the best portfolios you can ever create. So then next talking about, so is there any doubt in this specific topic, anything that you pops out to you if you want to ask about? Uh, Akshat, were you asking something?
No, sir. I was just saying that it's clear, sir.
Okay, okay, cool. All right, so yeah, so this is basically about like having a game design document. Then next we There are like just 2 sample videos. I'll share this link. You can watch it on your own, but I'll just quickly go through it. It's a long video. So I saw this like some random channel somewhere. So this is a good uh, example of a complete story game in shooter scenario itself. So like it starts with a story of something has happened, blah blah blah, some infestation has happened, all those things, and then basically it goes to the character. Like this is also part of the story. So they have what this person or a studio, I don't know if this was work of a studio or a single person. So they've created a very good storyline for per se. Something's wrong with my net. Yeah, sorry, I got disconnected. Uh, so basically, then it goes on for a storyline. Someone on call defines the mission for this person. Then basically they go on and have the shooter scenario in one of the scenarios that is there. So this kind of like this is a very good video to gain inspiration from and to learn how to basically create your portfolio video and game in a very concise manner. So like one scene which is completely entirely built, all the lighting, all the story point, all everything is perfect. So this is something that you can look on your own. And this is basically a concept video again, which is like a game where if you can hear is using a lot of spatial sound and spatial lighting, as you can see. So this is something that I just wanted to show you. Obviously, this is very complex to build and takes a lot of time to learn these things. But you can try and build a prototype similar to this, not complete with lighting and everything, but uh, uh, the mechanics of the audio and all those things are fairly simple, right? So this is again a uh, good video that I found that I wanted to share with you. So I'll share this link with you, and I'll keep adding resources here itself, either reference portfolios or resources other than the game design sample document. There are a lot of PDF documents that I have with respect to level design and multiplayer networking, a lot of resources which are like pinpointed specific to a topic or specific sample documents are there. So I'll share those here and you can come here and refer whenever you want. So that was till what we have till here. And then next we can actually start with AR now. So this again, if you remember, we've already seen this slide uh, in like our very first session. If you remember, so AR is in general basically where you try to superimpose a computer generated image on the real world, right? And we can try to basically enhance the natural environments or situations and offer perceptually enriched experiences. So I'll just go through the session one slides only quickly and walk through what we discussed there. So we discussed devices, marker versus markerless, SLAM, and geolocation, 4 things very quickly. So devices, we saw head-mounted displays, which is similar to like what you would use in VR. So HMD-based devices, which is like HoloLens or Magic Leap, those kind of devices. And now also Oculus Pass-Through is also there for a lot of mixed reality stuff. And then there are 2 different kinds of this HMD devices, optical see-through and video see-through. So optical see-through is like devices like HoloLens and Magic Leap, where basically you are seeing directly through your eyes the real world. And then the component that is virtually augmented is on a screen in front of you. In video see-through, you are seeing everything through a video only. So the uh, real world also is you are seeing through a camera's video feed. You're not seeing the real world as well directly. You're seeing it through a screen. Then we have holographic displays and handheld AR. They are self-explanatory, and handheld AR is what we are going to work on because we will be working on mobile AR. Then marker-based versus markerless, again, self-explanatory in the images itself. Marker-based have some kind of a target image on which only on those images will something specific spawn. Otherwise, it won't work. And then markerless basically is what uses your information about your surrounding, like try to find a plane or like a horizontal plane or a vertical plane and trying to augment something there. There's a more concept that I've added to this, so I'll switch to that after this. And then there's SLAM, which is basically the technology for uh, mapping your environment. So simultaneously localization and mapping, which is used for scene recognition and object recognition. So which we'll see in action in a way. We'll see this kind of a point cloud and then planes generation being done, which we'll see right now. Uh, then yeah, so then the final thing that was there was the Unity tech stack, which we'll be talking about. We'll be looking into AR Foundation and how we are using AR Foundation for developing for uh, Android as well as iOS. And then we talked about specifically for these. So this thing has updated a bit from the last time that I showed you this. I think I added this like a very old version maybe because it might have updated previously as well and I just added a wrong version. So I'll just show a updated version of this. So coming to this, the thing that I was talking about, two different things with respect to, like we talked about marker versus markerless. Then there's location based as well as superimposition based AR as well. So location based, as you can see, if you're near a building, if you're near a monument, then you point and you have specific information regarding that specific location, right? And superimposition based, if you see the video, like a specific machinery or a specific object, anything basically, which you want to impose on top of that itself, top of a real thing itself. So like, let's say I want to do installation of an AC and for the install, like the help of like eventually like the person who has to install it, for his help, I create an AR application, which if he uses his phone and uh, like puts it on the AC, then it will superimpose a virtual AC on top of it and then show instructions that first step is this, second step is this, third step is this. So something like that. And then there is this thing finally here that I've written here, also location anchors, cloud anchors, which is similar to this location based, but cloud anchors with location anchors would basically mean that anyone can come here and see the same thing. Like if I also add something there, then another person can come and if in that location see that same thing from their application as well, is what cloud anchor would mean. So like a public AR based setup where whatever I add in an environment wherever in any location, another person in within that application is also able to come and see that. So this is what I was talking about. Uh, my session objectives are written here. Okay, so this is the session objectives. Like we'll look into AR and XR packages and we'll start setting up an XAR project. Anyway, so this is the improved or the updated version of that document where basically, as you can see, almost all the features are now supported in AR course as well as AR kit. So they are similarly supported. I think ARKit also supports meshing, which is not picked here somehow. But I read somewhere, maybe it is not supported through AR Foundation, maybe it is supported separately. So, but as you can see, it supports device tracking, plane tracking, point clouds, anchors. So anchors, we talked about cloud anchors. So that is what an anchor is: light estimation, environmental probes, space tracking, meshing. So we'll look at some of these things. And let's go to some of the example documents or some of these reference documents. So what is AR Foundation, right? So we like this is the whole manual of AR Foundation is present here with how to install it, what are the subsystems that are present in this, what are the uh, different things that are there, right? So anyways, so let's go here on. So AR Foundation allows you to work with augmented reality platform in a multi-platform way within Unity. This package presents an interface for Unity developers to use, but doesn't implement any AR features itself. So AR Foundation is not implementing any AR features on its own. It's just kind of a wrapper on top of AR Core or AR Kit or OpenXR. So for three different scenarios they've mentioned here. For Android, it is AR Core. For iOS, it is AR Kit. And for HoloLens, it is OpenXR plugin, which basically it is implementing. And as you can see here, this list, yeah, okay. So I think this is a bigger list and some of these things are not supported till now, right? So some confusion there, but this is like, this is the final thing. The list that I showed you, this is a limited list. As I said that some of the things are not included here. So some of the things that ARKit supports, but AR Core does not support. So which means that iOS supports, but Android devices will not support is 3D object tracking and meshing. Like I said, ARKit does support meshing. Then 2D and 3D body tracking, collaborative participants, human segmentation, these things are not supported by AR Core devices. But eventually, somehow they'll come up in picture soon. For now, if you have an Apple device, you can try these things out as well. So yeah, so we look into setting these up and how to add this and then go about adding this. Then next, basically, this is a document of because I'll be implementing everything on an Android platform. Uh, we don't have enough time to go for a uh, like on iOS as well. If we had time, we could have done that as well. But right now, we don't have enough time to go there. So that is why we'll be limited to this only. So this is a page which tells you about AR Core supported devices. Um, Now almost all devices support AR Core. Android devices, almost a lot of them support. But even in case you want to check if your specific device supports it or not, you can come here and check. I remember there was a time when, like 3 or 4 years ago, when we used to check this a lot because they were adding new phones every week or every month. So we had to come here and check if our phones were added or not. When AR Foundation was not there, AR Core was a separate thing, AR Kit was a separate thing. So that was a different time. But now, obviously, a lot of things are added. And one good thing about AR Core is that it also supports development for iOS as well. Okay, so some of the devices that also iOS devices which support AR Core are also there. So like, let's say if you implement something in AR Foundation, which you have just used, or like, let's say you don't use AR Foundation, you use AR Core directly. And for some reason you want to switch to iOS now. So then some of the, like the features that work with uh, iOS would work as is with AR Core directly. You don't have to implement it with AR Kit as well.